Assalamualaikum and good morning. Today I would like to give my answer for question A. Okay, for part A, we are asked to form three simultaneous equations with three endogenous variables, which are Y, C, and T. First, we look at the national income equation. Aggregate income Y is made up of consumption C, autonomous investment I0, and autonomous government spending J0. So the first equation is Y equals C plus I0 plus J0. Next, we look at the consumption function. Consumption C depends on autonomous consumption C0 and disposable income YD. Disposable income is defined as income minus tax, which is Y substitute T. So we substitute this into the consumption function. The second equation becomes C equal C0 plus B bracket Y substitute T bracket. Finally, we look at the tax function. Tax T consists of autonomous tax T0 and proportional tax, which are depend on income Y. So the third equation is T equal T0 plus Ty. In conclusion, we now have three simultaneous equations with three endogenous variables, which are Y, C, and T, and this completes part A. For part B, we are required to transform the three simultaneous equations into metric form. First, we rewrite all equations so that the endogenous variable Y, C, and T are on the left-hand side, and the autonomous terms are on the right-hand side. From the income equation, we rearrange it as Y equals C plus I0 plus G0. We rearrange as Y substitute C equal I0 plus G0. Next, from the consumption equation, C equals C0 plus B bracket Y substitute T bracket. We rearrange it as C substitute BY plus BT equal to C0. Then, from the tax equation, T equal T0 plus Ty, we rearrange it as T substitute Ty equal to T0. Now we write these three equations in metric form, where the coefficient of Y, C, and T form the coefficient matrix. The variables are written as a vector and the constant from another vector. In conclusion, the system of equation is now successfully written in metric form, which complete part B.
My name is Muhammad Mira bin Abdul Rahman. My metric number is 310061. This slide shows a 3 times 3 matrix A representing a simple macroeconomic model. The variables C, Y, and T are consumption, income, and tax. Vector B contains exogenous terms, autonomous investment and government spending, autonomous consumption, and autonomous tax. The key step is checking if the system has a unique solution by ensuring the determinant of A is a non-zero. We compute the determinant step by step. First, we will expand along the first row. The first minor gives 1 times 1 minus B times 0, which is 1. The second term involves negative 1 times the determinant of the submatrix excluding the first row and the second column, which simplifies to negative B plus BT. With the minus sign from cofactor expansion, this becomes positive B minus BT in the full expansion. Putting it together, determinant equal to 1 minus B plus BT. Given that B and T are between 0 and 1, the determinant is positive and not 0. Therefore, determinant A is not equal to 0, meaning the matrix is invertible and the system has a unique solution. This slide based directly on the previous one. Having confirmed our system as a unique solution, we now move to find it explicitly. We begin with the same matrix A and our vector for the unknown X and the external input B. The co-equation remains A times X equals B. The direct path to the solution is to use the inverse of matrix A. The solution vector X is simply the inverse of A multiplied by the input vector B. The formula for the inverse of matrix is the reciprocal of its determinant that is multiplied by a special matrix called the adjoint of A. This last matrix in the middle of the slide shows a step in calculating the adjoint. It appears to be the matrix of cofactors where each element is computed based on a smaller subdeterminant. From this, the adjoint matrix is assembled, which you see here in a simpler 3 times 3 form. Finally, we apply the formula. The inverse of A equals 1 over the determinant multiplied by this adjoint matrix. This final box result is the operation rule. By performing this multiplication with any specific vector B, we get the previous numerical value for income, consumption, and tax. This slide delivers a complete, explicit solution to our macroeconomic model. On the left, we see the fully variety inverse of matrix A. On the right, we have the three final equations that solve for y, c, and t. These are the practical results we have been working toward. First, let's look at the inverse matrix. It's presented here as a 3 times 3 matrix where each element is divided by the same denominator. There is 1 minus b in bracket 1 minus t, which is mathematically equivalent to 1 minus b plus bt. Notice the structure that row 1 gives the solution coefficient for y, row 2 for c, and row 3 for t. For the final answer, we get y equal to c naught plus I naught plus g naught minus pt naught divided by 1 minus b in bracket 1 minus t. Next, c equal to c naught minus bt naught plus b times 1 minus t in bracket times I naught plus g naught in a bracket divided by 1 minus b times 1 minus t in a bracket. Lastly, t equal to t naught times 1 minus t in a bracket plus t times c naught plus I naught plus g naught in a bracket divided by 1 minus b times 1 minus t in a bracket.
For C2, we are going to use Cramer's rules to find out y, c, and t. First, we write out the coefficient matrix A and x, which contain cyt, and b, which is the constant function matrix. By replacing the first column of matrix A with b, we can find out and get a new matrix which is ay. By calculating the determinant of ay, we divide it with determinant A so we can get y. By using the same way, we replace the matrix A column 2 with matrix B and find the determinant of AC and divide it with determinant A. So we can get C, which is CO minus B T naught minus A naught plus G naught bracket minus B plus BT over 1 minus B plus BT. To get T, we replace column 3 of A with matrix B and we get AT. Then we find its determinant and divide by determinant of A. And we get T equals to T naught minus B T naught plus T bracket C naught plus I naught plus G naught over 1 minus B plus BT. For C3, we are going to use substitution method to find out what is Y, C, and T. By using substitution method, our last purpose is to let the right hand side with no any equation of Y, C, and T. First step, we list out all the given macro function. Second, we need to find out what is C to substitute it into function Y. To do this, we sub 4, which is yd, equals to y minus t into 2 and simplify it. After we find out what is C, we can sub it into 1 to find out Y. To find out Y, we need to change all the function with not to the right hand side and leave the left hand side with y minus by plus bty. By this, we can factor out the y and let the rest be divided with I naught plus g naught plus c naught minus bt naught. So we can find out what is y. By having y,
We sub it into 3, which can help us to find out what is t. First step, we make it the denominator be the same and open the bracket of numerator so we can find out what is t. To find out c, we need to use the equation 5. First, we extract the y from the equation of c and substitute the y with the equation that we get before. After changing it to the same denominator, we open the bracket and simplify it to get the final answer c.